Today our goal, our learning objective is to solve for x using angle and segment addition, which we're going to explain on this notes sheet here in a minute. Your warm-up was to get started trying to solve these three columns, okay? So I see mixed results, but I hope for those of you who have done stuck. I still want you to trust because I'm doing your stuff so I can see what you're thinking. All right? So notice that we're simplified. It didn't say the word solve. You cannot solve unless there's an equal sign, right? If there's no equal sign, you're not going to do opposites. You're not getting rid of anything. The only thing you're really going to do is combine like terms, right? So what are my like terms?
4x.
I got x's, 4x and 2x. All right. What does that give you?
6x.
6x. And then my constants, the numbers by themselves, 3 and minus 1 gives me 2. So plus 2. That's it. So it's not x equals something. Simplifying just means if you have more than one term that's like, you combine the like terms. Okay? So below it, let's try it again. What are my like terms down here? So yeah, again, below simplify, I got negative 2x, right? And plus 4x. So what's negative 2x plus 4x? A positive 2x. Now, if you're not too awesome at adding and subtracting positive and negative numbers, we will have calculators tomorrow. That's the plan, okay? Now, that's 2x. When I combined it, I got to bring down this constant, this 4. And usually our constants are after the variable, after x. So I'm going to put plus 4 over here. If you put 4 plus 2x, it's not wrong. It's just there's an order that usually happens. Ascending powers. Okay? There's that. Now the next one says to set equal. This time, since there's an equal sign, we're going to solve the way we've been doing it on our warm-ups the whole last week. So, on this first one, I have a 3x and a 2x, and they're on different sides of the equal sign. Do I combine my terms, or do I get rid of the smallest one? Okay, so we are going to get rid of the smaller x. You can only combine terms if they're on the same side of the equals. Since these x's are on different sides of the equal sign, let's get rid of the smaller x. Which x is smaller? 2x. How do I get rid of a positive 2x? Minus 2x. So, let's do the math here. 3x minus 2x is 1x. Now, usually you don't see 1x, so we're just going to write x. Bring down, plus 1, equal sign. Now, this can be tricky for some people. What is 2x minus 2x? 2x minus 2x. So it cancels out, and we have to put something there. You can't just have an empty space. So we put 0. Okay, some people that I've seen in the past will put x. You know, x means 1x, and 2 minus 2 is not 1. Okay, 2 minus 2 is 0. So even if you put 0x, that's close. 0 times x is 0. Okay, so you got to put something there, and it cancels it all out. 0. Now, last step here, x plus 1 equals 0. What do I do? Opposite of plus 1 is minus 1. So 0 minus 1 is negative 1. Now, below that, let's try it again. X is on both sides. What do I do? Get rid of the smaller x, which is 1.5x. Since it's positive, we're going to subtract minus 1.5x minus 1.5x. So 2 minus 1.5 is a decimal, but that's okay. 0.5x. Put down. Minus 3 equals, and then 1. I see two numbers. I know it's a two-step problem, so let me get rid of what first? Loner, which is a constant. How do I get rid of that loner? Minus 3? Opposite. Plus 3? Plus 3. 0.5x equals 4. So we haven't seen a decimal in front of x yet. By the way, what do I call this thing in front of x? Coefficient. So remember that word, coefficient. Anytime I'm getting rid of a coefficient, whether it's positive, negative, or even a decimal, what are we going to do? Divide. So let's divide by 0.5. It's kind of weird to divide by a decimal, but it's okay. And I'll help you out with this one. X equals 8. Okay? Again, when we have calculators in our hands, it'll be a little easier. All right. Now, these two columns, we're going to combine both of these ideas into the last column, where we're going to add and subtract, then solve. Okay? So on the last one, we're going to simplify and then solve for x. So, first one. I have a whole lot of terms on the left side. Anytime you got a lot of terms, always try to simplify. Always combine like terms first. What are my like terms?
2x and 4x.
2x plus 4x is
6x.
6x.
Plus 6.
And we have constants, -1 plus 7. And by the way, don't forget, if there's a minus sign in front of a number, that's like a negative. Right? So -1 plus 7 is 6. Okay, -1 plus 7 equals 180. So we have 6x plus 6 equals 180. Obviously, I need to get rid of a6, but which one? Lower, which is this plus 6. The opposite is minus 6 minus 6. So 6x equals 174. And since 6 is a coefficient, we are going to divide. And we get, I'll help you out, 29. And I heard this earlier today, and you may be aware of something called InSolve in these yellow calculators, Inspires. But just so you know, I'm showing you and demonstrating that you can show work because I expect you to show work. Okay? So again, using the calculator for computation, adding, subtracting, multiplying, dividing, fine. But if I see answers that work, you know what I think about that. Okay? I don't know what to think about it. Either you're a genius, or you might be borrowing someone's answer, aka that bad word, cheating. So, since I can't tell the difference, show your work. Next one. I have like terms. 4x plus 3x is 7x. Bring down the -1 equal sign 90. Two-step problem. My lower is -1, so I'm going to add 1 to both sides. 7x equals 91. The coefficient is 7, so we're going to divide. And 91 divided by 7 is 13. Read that a little bigger than those. It's 8 on the other. So that's the first part, that's the warm-up part. Now we proceed to the practice problems. Okay? Now, before we start the practice problems, I want to make sure I give you the notes. And the notes today are so quick you might blink and miss it. So focus. Right? Here's what we know. The notes for today are part plus part equals whole. If you have segments or angles, or honestly anything, all of the parts will add up to the whole. So that's just an idea that I'm going to show you what it means on number 1 and 2 down here. So just remember, anytime we have parts and we have a whole, that's the equation. Part plus part equals 4. Okay? So number 1, it says first of all, no picture, right? Now, if you like pictures, this is a bummer, but you can draw your own picture. Okay? So number 1, given R is between Fy. So that means I have to have a segment Fy, and R is going to be somewhere between. So I want everyone to follow along with me. Let's draw Fy as a segment. Draw it kind of long because you're going to need some room. Fy. So I just drew a segment Fy. Okay. And it says there's a R between it. Between does not always mean exactly in the middle. Okay, so anywhere between, I'll put it like right here. Friday. Don't you wish it was Friday? Well, it's Tuesday. At least we have a short 4-day week, right? So we got Fy. Always more often when we grab that sheet over there. So that's what we're working on. So now we're going to label Fr and Ry and Fy. Okay? So what does it say Fr is right there? Segment Fr equals 3x minus 2. Does everyone see that right here? Real 0. Right. So let's label it 3x minus 2. Between F and R, we have 3x minus 2. That's the part. Okay? Now, the next part is Ry. Do I know that? I do. 4x plus 7. And so we got Fr, Ry. And then the whole thing is Fy. And it tells us Fy is 96. So I'm going to show them with like a bracket, like a big bracket. The whole thing is 96. So if I get a picture, a picture of what we're dealing with. Once we have a clear picture of what's going on, now we're going to apply what I have here in green. Part plus part equals whole. So let's go ahead and write an equation for that. I'm going to always put my parts in parentheses. So this part plus this part equals whole. So let's write it down. The part Fr plus the other part Ry equals the whole thing Fy. These are all segments. Okay. Fr plus Ry equals Fy. So here we go. Fr is 3x minus 2 in parentheses plus 4x plus 7 in parentheses equals the whole thing from F to Y, which is 96. Okay. Give me a second to write that down. But I want you to reflect. Does that make sense? Why we made that equation? If you know a part, just add them up with an equal sign and then the whole thing. So again, we're using the in green up here, the numbers. It works for segments and it works for angles. Now what's left to do is obviously algebra, not mess it up. So let's try not to mess this up. We talked about it at the top of this page. What do I do with the stuff on the left first? We are going to simplify by combining the like terms, right? So you see those x's, let's combine them. What's 3x plus 4x? 7x. So our constants, negative 2 plus 7 is 5, so plus 5. And that equals 96. just like we did up top in that third section. Combine first, then you have a two-step problem. Get rid of the loaner, and divide. So my loaner here is 5, so we're going to subtract 5. 7x equals 91. And just like we did up top to the right here, 91 divided by 7 is 13. Okay. So this is called the segment addition postulate, where we're combining parts equal to the whole. Now, number 2 is a little bit nicer because we have a picture to work with. So let's think about this. So, do we know the first part? Good. It's right here. Do we know the second part? Over here. Do we, in the picture, know the whole thing? Not from the picture. Always read your problem, right? Solve for x given qs is 15x plus 2. qs, now that's the whole thing. That's the whole. So let's write 15x plus 2. So now you can see we have a part and a part and a whole. So same idea. Part plus part equals whole. And I'm going to set it up the same way. My first part is QR plus my second part is RS. And that's going to equal the whole thing, which is QS. So I'm kind of writing my parts. Take the S. Let's fill it in with what we know. QR is 5x minus 2. And I'm sorry, there's not a lot of room on your page. Try to write small. Plus 10. QS is 15x plus 2. Just like the last one, we're going to combine like terms. You'll notice there's no x's to combine, but there is constants. Negative 2 plus 10 is a positive 8. So I break down 5x plus 8 equals 15x plus 2. Okay, x is on both sides, so we get rid of the smaller x, like we did up top in the middle section. Minus 5x, minus 5x. 8 equals 10x plus 2. And it's a two-step problem here. So we can get rid of the loaner on the right side, which is positive 2, by subtracting 2. And this is weird. 6 equals 10x. We're not going to end up with a whole number. Okay? To get rid of that coefficient 10, we divide by 10. And we get 6 over 10. What does 6 over 10 reduce to? So as a fraction, you can divide them both by 2 and still get a fraction, 3 over 5, which is their decimal, 0.6. Okay? So it depends on what I ask you for, fraction or decimal, but always reduce your fractions. All right? Now you can move it over. We're going to talk about these next two. Has everyone got this down before? Okay, so you flip it over, and you see these angles. And my question is, on both of these, what is this angle pair? So does anyone remember from their notes from Friday, what do we call angles that are across from each other?
Can I help? I would say, remember Segmwent or kindergarten? So
Marino
crisscross applesauce, that's a vertical pair.
Ms. Marino says crisscross applesauce, that's a vertical pair. All right, so if you look at your notes, it looks like this. If you remember, across from each other means vertical, and that means they are down here the same measurement. So notice right here, these are both 158 across from each other. These are both 22 across from each other. So again, the name is vertical angles. So let's go through that Right. Vertical angles, because they're across from each other. And we said that means they're congruent, or they are equal in their measurement. Okay? So that means this and this are equal. So what would I write for an equation? Do I add them up to something, or do I set them equal? If they're equal, you set them equal. Okay? So whenever you have vertical angles, all you got to do is put an equal sign between them. Because you know they're the same. We just talked about it, right? So let's make that equation. 6x minus 12 equal sign 3x plus 18. So unlike the last two problems we did, where it was part plus part equals whole, we know vertical angles always have equal signs between them. And we can solve this, right? So the smaller x is 3x. We're going to subtract 3x from both sides. 6 minus 3 gives us 3x. Bring down minus 12. Equals 18. Two-step problem. What do I get rid of first?
12.
Owner is minus 12, so we're going to add 12. 18 plus 12 is 30. And to get rid of this 3, we divide. So x equals 30 divided by 3, 10. Okay. Again, we're going a little bit quicker with the algebra because we got to practice on the front side of the sheet, top half. We got this. Now, this might seem tricky, but what do on number 4, what do I call these angles that are left and right of each other? They're across from each other, so what do I call them? They're still vertical. Now, I know vertical means up and down, right? But in geometry, when the angles are across from each other like this, that means they're called vertical angles every time. Okay? So since these are vertical for angle pair on the right, vertical. And since they're vertical, like we just did, what do I put between these two terms? Or these two expressions? I put an equal sign because they're equal, because they're congruent in angles. All right? And everyone just follow along. No headphones. 9x minus 10 equal sign 8x minus 2. So just like last time, get rid of the smaller x. Minus 8x minus 8x. What's 9 minus 8?
1x.
So we would get 1x, but we're going to just write x. Bring down minus 10 equal sign negative 2. And my last step to get rid of that minus 10. Plus 10, negative 2 plus 10 is 8. So x equals 8. All right. So that's our stuff. One of the notes because we're almost near the end of class, but it's a reminder. You should know how to simplify. You should know how to solve for x when x is on both sides. You should know how to do both, where you take the line curve and then solve for x. Remind me, if you see something like this on number 3 and 4, if you have two parts and a whole, what do we do? Part equals whole. And if you see vertical angles, you set them equal. Right?